started today, we do have a big lab, but what I want you to do while I take some attendance, I would like for you to go through to the front, which should be a refresher, because you just took a quiz on this. So if you were unhappy with your quiz grade, here you go. If you were happy, then this should be easy. Okay, so you guys can do this. The back is going to ask you a little bit about the models, all that kind of good stuff. If the back was a test, could you do it without looking at your notes? That's the question. And then we will get into the lab today. All right. All right, those of you at home, hopefully you paused the program and we took a look at this. What is Z? Z is the atomic number. A is the atomic mass. All right, let's do it. I'm going to give you the numbers. Hopefully you all know how to do this. So we're looking at 4, 9, 4, 5, 2. And then you put the mass on the top, number on the bottom, and then the charge. All right, let's knock it out. Next one, 53, 127, 53, 74, 54. See, it's your -1 charge, and then your full atomic symbol. Yes? Preguntas? All right, let's do it again. 10, 20, 10, 10, 10. I said that many times. Good. Next one, 15, 31, 15, 16, 18, and then your full atomic symbol. Nice. And then the last one, 19, 39, 19, 20, 18, and then your full atomic symbol. So again, this should be easy. You already took a quiz on this. We should knock it out of the park. Let's flip this over. Bohr's model had a nucleus, and then it also had these things. What did he call these little paths that the electrons took? Orbits. And so he thought the electrons, how did they move? He thought they orbited around the nucleus like planets around the sun. He also thought that energy was low and high. Where is low energy?
Low is towards the nucleus, high is away.
That's how much energy it takes to be there. Now, he could predict the colors that we saw yesterday of very simple elements. The best element was what? Hydrogen, because it only has 1 proton, 1 electron. It's not hard to guess where electrons are going if you only have 1 of them. Over time, do scientific models become more complex or more simplified? More complex. Why?
Because people get smarter.
Yeah, all that stuff is right. You gain more information, you make new discoveries, you learn new things. So at the very beginning, what did we think that an atom looked like? Good. Dalton said, hey, no pieces, no parts, just looks like a marble. Then what did we find next? Good. Thomson said, hey, I think that this mush has what charge? Positive charge. And the plums have a negative charge. And so I think it looks like plum pudding. Then what do we find next? The nucleus. And Rutherford found that. What was his model? He thought most of the atom was? Boom. So he had a teeny, what are 3 things about his nucleus? Massive, small, positive, nucleus, and then the rest of the atom is nothing but empty space. And then good old, who came along yesterday? Bohr, and he said, yep, planetary model, however you want to say it. We still have a teeny tiny positively charged dense nucleus, but now we have our electrons kind of going in these orbits. You see it's getting more complex over time as we find more things. Yep.
Do the last 2 models have like specific names?
No. This could be called the planetary model. That's a very good way to say that. And then this one, can I just say lots of space. His biggest thing was the nucleus. Okay. Got me. Questions? All right, so put your pencils down, relax real fast. I want to recap, just in case you weren't here yesterday, on how electrons actually emit light, because you need to know that for today and a test and all this stuff like that. So electrons have to start in what state? It's called the ground state. Good. And ground state is the low energy picture. And remember, we have low energy close to the nucleus and high energy is get away. So if I were to take this electron here and I wanted to put it in the low energy state, where would I put it? Right here. Okay. And there are rules we're going to learn next week about how many electrons can go in different places. So we have the low energy state. The ions here in these test tubes are in the low energy state right now. They're in the ground state. Then what do we do in order to get them to do anything? Add energy. So step 2, close nucleus, low energy. Then you got to add energy. When you add energy, what's that state called? Excited state. And in the excited state, what do these electrons do? Oh, you know it, like Chris Cross said. Where is the song? I don't have it today. It's on my playlist. You'll get it later, Ken. Sorry. So they jump to this high energy state. It's called the excited state. Can they stay there forever? No. What happens? Oh, they fall back down. Law of conservation. You got it. They release a photon of light. Good. And that is what we see as light. So as they fall back down, they release a photon. And that's what we see as light. Different colors have different amounts of energy, and here's just a little graphic of what they have going on. So as this blue electron falls back down, it releases a photon. The more energy it releases, the more violet the color. The less energy it releases, the more red the color. Okay, so it depends on how far it falls. There's math you can do with all this jazz, but it's not required of us. So you're just going to go by the color. Okay? All right, so put your lab in front of you. You got it. And so I'm probably going to pause this recording. I will go back into lunch and explain to everybody at home what we kind of did with the lab, but no need for you to listen to this portion here. All right, those of you watching at home, so what we have here, let me unpause this, is we did this lab. And so basically what happened in class was we burned these different ions. They were in solution, and we burned them, and we tried to see the color of the photon that was released when the electrons fell. And so I have this video here. I'm going to post it, but I just want to talk about it a little bit so you can kind of see the setup. So they had a Bunsen burner. We turned the lights off in the classroom. They had a nichrome wire, which you'll see this lady bring here in a second. I did not make this video. I just found it was the best one I could find online. And so what she's going to do is she's going to put a nichrome wire that has a little bit of a couple drops of solution on, and then you're going to see a color appear. And so this is the lithium ion that's been burned. And then you will see, and she'll clean her wire, will turn yellow, and then she'll add some different flames, like this is a potassium flame. Things like that. So what I would like for you to do, if you don't mind, it's a really great video to watch, and you can just see the different colors of the different ions. And then when you come in tomorrow, you will not miss a beat. And, oh, you're fine.
Oh, were you?